Good evening, friends. Welcome to Eastern Academy. We are into embedded system programming, week 13, day 2, and session 1. And today we're going to discuss about something what somebody has asked the last class. It's about simulation versus real hardware. What is the difference? Whether I should do work on simulation or work on real hardware. That's the trick. You should know when to work on simulation, when to work on real hardware. That's a trick. Okay, so you know that very clearly. The change is inevitable. The world is keep on changing. For example, very recently, about a year back, I worked on a project which is making a full chip. The entire chip, the software was tested on simulation before the chip was released to the fab house. Because if it does not work, you think of it a moment. After chip is come out, we cannot test the software because it's a lot of risk involved. There are about millions of dollars, not 1 or 2 rupees. It's about millions of dollars is a penalty. That's why we used to do the Pakka testing, the chip. And there are two things other. One is called simulation, one is called emulation. What is simulation? What is emulation? Simulation is what you do it on the software. Whereas emulation is you work on a hardware which may not be the same hardware, which should be a slightly slower version or different kind of things. So that's the way the whole world is working today. Please understand, even NASA, before sending the crew to the space, they do simulation. The trick here is we are living in 2021. You should know what is available the fast and how to make it so fast. Today, what is the requirement of the industry? That has to be understood by you very clearly. Okay, let me share the board and draw it. The board, I may not write it perfectly because I made it to show the simulation, on the hardware, but let me try to somehow manage it. Okay, so think of it. You have a hardware or CPU. You call this as a CPU. And I have some input signals. I have some output signals. So the trick here is, the first class system I told, the relation between input output is called embedded electronics. This is called embedded electronics. Please understand. This is called embedded electronics. Whereas this is called embedded system. So what the industry looking for today in 2021 is somebody should be able to write a good program here. And from here to here, the connecting the hardware, that is sensor or devices, that somebody is taking care of that. That you may call it as hardware engineer, or somebody is taking care of that. What industry is looking for is There's a change from yesterday to today. Today, they are looking for, are you good at that? Programming. It's a very important aspect. Or this is only not only CPU, this you can call it as a microcontroller or SoC or whatever called. Understood? So here is a place, the simulation plays a very vital role. So I'll show you just now how the simulation and the real hardware, what we do is correct. I want to prove it to you a minute. Okay. So what we did was in the simulation, we tested. See, please make sure that don't look for this. See, I would have never shown you this if it is going to be Arduino board. Please understand. Why I am showing this is one reason. If you see this board, I do not use as Arduino board. Please. I use as a port. Today I'll explain to you that how we do it in ARM and everything. Okay. The same thing here. That's also we are also discussing in the ARM class. Coming classes in ARM microcontroller everywhere, we will discuss about how these things are going to play a vital role. This pointers and the direction register and everything. Nothing more than that. So what I have done here is I connected 8 LEDs. I hope you are watching. You could see my screen. Then I was asking you to do this exercise on this. Of course, you can do it on hardware also. Now I ran the program. It's blinking the LEDs because I blink the LEDs because these two are used for TX and RX. Am I right? Unfortunately, Arduino boards, the port D, they use for, that's what I've written here, port D. See here. The address is 2A. Direction register. And then we have out register. And we are outputting FC and 00. That's why it's blinking. You can change anything here. I can change here 80. Only one light will blink because 8000. You could do anything here. I put F0. Only 4 LEDs. Understood now? So, there's a trick now. Now let us see that. Let's stop this. You have seen that I've written a code on the, I connected to port D and I made it on direction as FC. All those 6 pins as output. Then I made the LEDs blinking. Now let us connect the real hardware. Let us connect the real hardware. Okay. So I have made a same Arduino board. Let me erase this. I made a small Arduino board like this. You could see that. This is same Arduino chip, everything is same. The only trick here, what I have done is this Arduino board, please. What I have done is I made as a pins, such a way that people can easily connect. You don't need a breadboard. Somehow I'm not very happy the breadboard for beginners. Once you are expertise, you can do a breadboard. You can connect like this. The cable. This is all board made by me myself, just for students. Unfortunately, after the pandemic, I could not be able to manufacture. Maybe I'll do it after some time. So Arduino board, all the connectors you see, port B, port D, and port C. All the ports are available here. Port C, port D, and port B. I've connected the wire on port B now. Same way, I have a board with LEDs. See that? 8 LEDs, 2 bicolor, and tricolor, and the 7 segment. All single board. Now I connect this connector here. I will show you that. How I connected. See that now? Port D of Arduino is connected. It takes only a minute. No breadboard, nothing. You should know, if you can cut a board like available in the market, you can buy this type of boards. They are available. I'll show you now. Okay, now this is for power. I connect this power to this guy. I given a power. So I given a power. See, I've given a power. I connected port D to the LED, 8 segments. Now, let me give the power, USB power. I've connected now. Hey, some program is there already. The flash, some program is there. Now we will change the program. Now what we will do, we will copy the program and do the same thing here. Let us see now. Let us go to the board. So here's Arduino environment. Okay, same thing. This is actually the Arduino IDE. This will make it bigger so you can see that. Now I'll do one thing. I will copy the other program. What we did it. Now what I'm trying to show you is that I'm trying to prove you that both are same. There's nothing called, we have a different mindset called about simulation and this one. I copy the same program now. See that? I cut and paste. I copy and put it on the Arduino IDE. Okay, let me now build it. Let me now compile it. Now it's compiling. So there is no errors. Okay, so let me now set the COM port. COM4, correct? So let me try to send the program, download the program. See? Oh, it is, which is software, there's no limit. You can use, every controller have a different softwares. Every controller is having a different software. There's nothing called a specific. Unfortunately, these microcontrollers don't have any a specific, this one, what do you call programming things. It's a very unfortunate. Now it's correct. Now this is it okay now. So see that I run the same program. I run the same program in the other environment. See here. Same. This is simulation. This is your live project. I have not done any changes. I have not done any changes for this. Okay. Now let me stop this. Let me stop the sharing. See, that is the reason I was not very keen. You have to have a stage. When I thought I will get into the real hardware, I'll tell you a small For example, I have a board called keypad, eight keys, 8 pins. You can connect that also to the board. Simple. Take this and connect with the cable and connect, give a power. That's it. Then connect it to the board. I know that. I know you will face a small problem in connection, but that is nothing to do with the embedded system. That is, please understand, that is a different, altogether different capability of handling the boards and hardware. This requires different thing. Now I've connected this switchboard. Then we'll give a program. We'll write a program for that. Okay, now let us get into the Arduino board. See, I made as a port D as a output port and port C as an input port. Then what I have done is I'm reading port C and writing it on port D. Port C as an input port and port D as output port. Please understand, this is same for every microcontroller. Please. That is what I'm trying to tell you once again repeatedly. This is for, now I'll tell you what has to be taken care by you. What are the factors? What is the difference between simulation and real hardware? Okay. Now I run this program. Compile the program. Then I'm downloading the code. Now its code is downloaded. Am I right? Now it's done uploading. When that code is downloaded. Now you see here. See here. If I put the fourth pin, because I'm reading the port and reading it output. Because forget about that Arduino board is having some problem. That means that 2 pins are not used here. In port C is having only 6 pins. That's a problem. Forget about that. If I connect to Arduino Mega, it will work. Of course, I made like this. See here, this is the board CPU. The same like Arduino, this is 8051. I have same like IoT. That is ESP32. And I have a same board like ARM. Understand? So once you have the board, the input outputs are same. That's what I want to prove. I made all the output boards and input boards are different. You connect any board as you like. The connection is in 2 minutes. What you're going to do, if you buy a breadboard, you have to stick the connection and do the thing. Now I'll come to the very important point. Let me get into the board. Let me remove the connection. I'll show you the thing. So that's why I always tell, if you wanted to practice any hardware, buy a hardware and let me know. I'll be able to give you, I'll share the board. You can share the screen on the Zoom. I will tell you how to work on it. Am I right? Any hardware you use it. But I'll tell you what is a but. The but is a very important. The but is a very important. So please 1 minute, because I have to show the, I made everything into the, what do you call it? Zoom mode. I have to adjust the camera a bit. Because I have to write a board means I have to be a visible board. Correct. Thank you. Okay. Now you could see the board. Now, let us try to understand what is the difference between simulation and the real hardware. That has to be understood by us very, very, very effectively. Otherwise, you have a problem. See, the simulation, one major problem is voltage and current. That depends on the simulation software. That depends on the simulation software. Are you going to pay the free one, cheap one, and costly one? Okay, if you buy a costly one, that does everything. It's almost equivalent to 100% of hardware. That depends on which simulation software you're working. But I always say the thing is that you are worrying too much about physical things. You are worrying too much about physical things, which we don't, because you are going to work in a company. That manager will not give you the project 100% to you. The manager will give you a small portion. That portion will be, he knows, the manager knows that what to give it to you. Okay, he will give you a small function. Or module. Please understand the reality that we sometimes don't see. You know the rule of, you please understand certain rules of the industry. That is called 80-20 or 90-10. Let us through the 80-20. I think most of you know about 80-20, 80-20 rule, 80%, 20%. If you buy a Microsoft software, any software, I'm checking Microsoft because we are using every day. You use the Word, MS Word. There's a big trick there. When you use the MS Word, you use 20% of software, maximum time, 80% of time. You use 80% of software, only 20%. That means that you will not be using, if Microsoft is having 10 features, you will use only 2. If Microsoft is using 10 features, you will use only 2. You will not use 8. Every software you take, you will choose only exactly what do you need. Nobody uses 100% of software. Okay, that's a trick. So, what we think is, what the Microsoft will do internally is, the 20% of software will be tested by 80% of people. Let's say I have about 10 people for testing. Because Microsoft want to release a software to market. Am I right? Before they release a software, they want to test the software. Now what they will do, the 20% of software, they know that, which is used by the user. 80%, 8 people. But for the remaining 80%, only 2 people will test. So do you understand now? What is the difference between 80 and 20? That means that in the software, you will use only 20%. You will not use 80%. The Microsoft will not waste the time. They will test only 80% because since this is going to be used by everybody, there should not be any fault. They put more people. This software somebody is rarely used. If there's a fault comes, we can manage. That's why they test 25%. Like that. you need to understand one thing. You should know in the interviews, in the interviews or at the work, you will use the 20% of knowledge 80% of time. 80% of knowledge 20% of time. You understand now? This is a trick. What we do in the interview is we check you are good at this or not. As a fresher or as a student, everything, you will give weightage for both. But since I'm an industry person, I cannot do that. If you give weightage for the everything, what you will do? You will spend here 8 days. You will spend here 2 days. Understood? So you will have only 2 days knowledge here. Here you have 8 days. But in the interview, I know that they're going to ask more questions on this. This, in the school, they will tell you, the lecturer and professor, hey, these are teachers, the school, basically school teacher. Hey, this is the important questions. They always put the symbol, tuck. That means it's important. Am I right? Like that here. We know that in this 20%, the most important thing is your 50%. Is your embedded software. Here is the one, your sensor and your other things. If you're done here, that's happy because why they are recruiting you. Please understand. You need to understand why they are recruiting you. If you know that concept, you will know that I am a manager. I'm a manager. I have to do 10 tasks. 10 tasks. But I know that this task is an easy one. But it takes more time of mine. I know the easy one. And this is a tough one, hard one. It requires expertise. Okay, I know that there are 2 tasks. One is easy one, it takes more time. And another one is hard one, it requires expertise. So what will I do? I want to save my time. I don't want to waste this time because easy one. So I recruit an employee. And I give this task to you. I know that I'm a manager, man. I have so many years experience. I know that this job, you don't have expertise. I will not give you this. But you think that they will give you this. No, we will not give you. That's why you ask most of the people, those who have joined the companies, they will say that, hey, we have been given a very simple task initial days. That's why. What I'm doing is, you are indirectly saving my time. Let's say this is taking about 10 hours. My 1 hour cost about 10,000 rupees per hour. What happened? My manager cost is, let us assume that 2,000 rupees per hour. And you are paid 200 rupees per hour. That means that 10 into the 2,000, 20,000 rupees. Am I right? Which you take for even 5 days, doesn't matter. And also you get trained. So please understand. I know that your curiosity of knowing everything, but what you should do here is, you should know simple thing. Perfect. So in the simulation, things are developed very well. I put WalkMe. There, you will do wonders. I myself tested. I've done a lot of projects and showed you people, everything I'm giving. So don't worry about this one, because which I myself, if you write a software here, it work. So where without spending the money, work day and night on this. And other software is very expensive. I'm not, since I cannot propose you on the other one, Proteus. It's a very good one that supports ARM to everything. Okay, so that's a beauty one. And second most important thing is, please understand all these things. All these things has to be understood by you very clearly. If you do not have the thorough idea of this, you will always have a confusion. You write a program in C. You are not writing in machine code or opcode or assembly. You're writing in C. Whether it is Atmega or 8051 or PIC or ARM, all are same, because you're going to see. And each and everything is having two parts, CPU and controllers. Please understand, when you write a program in C, when you compile it on any of the compiler, it will work. That is a reason. See, the main reason you went for C is that there is a high-level language. That's a high-level language. And you went for the C because high-level language, and the program will work everything. But now you are coming and telling me that I have to learn all of them. I'm confused. To be honest, you basically defeating the purpose of why they invent the C language. What they have done is, they have a different compilers. That's not your problem. So that is not your problem. So please don't get confused too much about your C. The C is common for all the, there will be a small variation, they're all fine. I told you 99% same, 1% will be a small variation. Forget about that 1%. Don't worry too much. You always go by, if you normally look at the thing, people will say, the professor said now the class on a whiteboard, he said that he put a small dot. He put a small dot in the center. He asked the students, what do you see? Every student said, we see a dot. Then he asked, why you don't see the white surface surrounding that? That same thing here. What you are doing now is what you don't know. And you are not trying to spend your time on making perfect on what do you know. You know this much. Understood? The same way here. So please, second most important thing is, it is not PIC. This is another confusion people have. PIC, 8051, ARM, Atmega. They have two things. Within the chip, they have a processor and they have controllers. So don't try to get attached to one controller. All the controllers are same. You have to read the data sheet and say that the controller has how many registers and how do you read it. That is it. Understood? Don't, then what will happen? You know only that controller. Tomorrow, if there's some other controller comes, you may not know that. So please understand, there are two types of controllers. That is another trick. One is within the microcontrollers, there's a controller. Within the microcontroller, there's a controller. Could be timer, could be interrupt. Within the microcontroller, there's a CPU. But there are controllers outside, connected through SPI or I2C. The beauty is, this is much more easy. The problem is, if you write a code on PIC for this one, DS1307, that is the RTC chip. The same code, what you have written on PIC, will work on ARM. It will work on everybody because you are going through the thing. The only thing what will vary is that how to talk to the I2C, because the I2C controller inside the microcontroller is different, and that's also easy. So what effectively what I'm trying to convey, you should understand what I'm trying to convey. Convey is master any one microcontroller. Don't try to put your leg on everywhere. Oh, I want to know 8051. I want to know that ARM. I want to know about this one, Atmega. Don't try to put your leg on too many things simultaneously. Put your leg only on. I told you that WalkV because because that is available for simulation free. Maybe once I buy the Proteus, I may tell you that you give you Proteus file also, I will check. Right now, I don't have Proteus. I have only WalkV. So that's a trick. So if you do the simulation and you share the code with me, I'm ready to connect and send you. Try to be perfect on this. So please go step by step. We are not going to stop today our relation. Please, in our step, you should say one day, sir, I have done C programming well. The moment you say, well, I will share the screen. I will give you the code. I will see how fast you write. And I will write the same code, how fast I am writing. Then you can compare. So please understand how good you are in C programming. Then, same thing, we do it on the WalkV simulation. Oh, done, man. These two you have done. Then I will say, Baba, move to hardware. Understand? This is a step you should follow. Without perfecting this C programming, moving to this simulation is wrong, which I don't agree. Try to solve your problem here. Then, see, let us think one thing. Take a Toyota. They make a car. Toyota make a car. If they find a fault within the factory, then they solve it. Suppose they miss a fault, they sell it out, sell the car. So many people bought it. So many people bought the car. Maybe about 100,000 people have bought the car. 1 lakh people. You know that they are simple. 1 lakh people. Now, if they find a fault, that means that when you are traveling at 160 kilometers, the brake is not working well. What they found a solution now, but they have to now go back. They have to withdraw all the cars and do the changes and send it back. You know, the amount of cost. The same thing here. If you do with the C programming, then move to simulation. It's very good. Otherwise, you have to come back. That's what I'm seeing all of you. There's nothing wrong with you. I know that you wanted to go fast. That does not work, which you don't know. The beauty is this will work. Your methodology is this. Your methodology is this. Your methodology is this. You will always grow. Always grow. It's very nice. But you will come back after some time. Because you don't know here, you get stuck here. Learning, then come back. Then you forget this, what you have done, come back a little bit. That's the way. What I'm trying to say is this method. That's all. Then nobody can touch you. So please understand. No, that's why I'm showed you the hardware today. The reason was, what is the difference between the simulation and hardware? So if you say that on simulation, think on simulation, I can do everything on LED very good. I'm very good at controlling LEDs. Then go to hardware, connect the LED and check the same thing, are you good or not. And don't worry about what hardware you buy. You buy a PIC or ARM or 8051, whatever it is, let me know. If you are finding it difficult to connect the LEDs, one of this platform, any microcontroller, let me know. Come back to me. I'll help you. Okay, now we start doing the hardware also. Then once you've done LED, then you connect 7 segment. When you keep on adding the hardware, you have to keep on spending the money. You have to keep on spending money every hardware. That's why my methodology is very cheap. Do everything on simulation. It will work. It will work on hardware. If it doesn't work, that time find out why it is not working. Then you will know the difference. Okay, don't ever think these two are different. These two are same. That depends on the simulation software. That sometimes will differ from the cost, based on the cost. Otherwise, it's quite simple. If you have any doubt on this, that is where the hardware. Okay, so please, I once again telling you that very important information. This information never forget. This information we generally forget, all the people. Never forget this information. This information is very critical. That is, when I write a program in C, you may be using a 8-bit microprocessor. You may be using a 8-bit. If I write a C program, long, I is equal to 25. Okay, I'll give you an example. Now, I write a program, let's say the C program, I write long, I, comma J. For I is equal to 0, I less than 100, I plus. J is equal to I plus. J is equal to J plus I. Am I right? I write some program. But this program, even though I say long, which is 64-bit, I have a microprocessor with 8-bit, 16-bit, 32-bit, 64-bit. But if I compile it, it will work on all the places. It will work on all the compilers. Yeah, same. Whatever it is, you can write J plus. Yeah, that's fine. That's all C. Okay. That's all C. You learn that. I normally don't. See, the problem is I do not use. See, for example, if I have to write a code like this, I never write like this. Even though if you put a bracket also, I don't do that. I'll say x is equal to x1 is equal to a plus b. x2 is equal to c plus d. X is equal to x1 plus x2. You think this should save time? No time waste and all. They are same. But this case compiler is going to do the same thing like this. The problem here is when I'm debugging the code, I put here printf x1. Here I put printf x2. Here I put printf x. So I know that is a fault. But in your case, if you do everything as a two, this. So always do learn to write simple programs. And first believe that if I write a code on C, if I compile it on the respective compiler, then on that microprocessor it will run. But one could be slow, one could be fast. That is your problem. That you should take care of it. For example, if you write a program, int I, for I is equal to 0, I less than 100, I plus plus. Understood? This program, if I give it int or short or char, all the three will give same result in ARM. But if the same program, if you put char, it will be faster in 8-bit. Short means better. Int will take more time. It's 8-bit. So you should know how to optimize that. So first, don't worry about C program. Running it on processor. That takes away compilers. Now, second one is, don't worry about controllers. So master LCD, timer, interrupt, everything. You master the controllers, then you'll be able to do things perfectly. Don't worry about controllers. Then a third one is outside I2C or SPI or whatever controller is there. That code is common for. See, what I'm trying to tell you is that, see, it's a very thing. There is a controller. Please understand, there are two types of controllers. There is a controller outside the chip. You connect it through the I2C. There's a controller inside your microcontroller. To understand, there's a big difference. This one, the code will be different. For example, let us assume that this is your Atmega. Or what do you call AT? Is it Atmega 328P, whatever it is. Now you have this. The beauty is this guy is having a timer. Now let us compare. I have a ARM ST Micro. Now I have a timer. Then I have a controller, RTC. Sorry. RTC. This is RTC. Please understand the difference between these two. This will be totally different than this. So you have to write different code for both. So you should read the data sheet of this timer. You should read the data sheet timer. But the beauty here is this one. Okay, DS1307, whatever it is. That outside controller is common for both. So the program what you have written here for this will work on this. So please understand, when you write a code in C, for the microprocessor it is same, but this controller is different than this controller, but this controller is common. So don't get confused between the controllers outside the chip and inside the chips. Inside the chip is a proprietary of that manufacturer, whereas outside chip is common for you connect it to any microcontroller will work. This is the trick. Now, if you have any doubt, ask me now. I'm ready to explain now. Any doubts, please. Now, fairly, I'm trying to explain that what you should look for it. That is, you are in a good stage now. You have to, first of all, make sure that where you stand on C, where you stand on today, I told you, I'm available. Even next class, you can come and participate. Don't be hurry. Don't be hurry. First of all, make sure that where you stand on C. Do the self-assessment. Where do you stand on C? Correct. You are right. These are all trick. J is equal J plus plus takes this time to increment than J. It's correct because that is the internal architecture. That's the increment and decrements are internal architecture of the chip. So J plus plus takes less time than J is equal to J plus 1. You are right. Fine. These are all called optimization. That please another thing understand. You are right. I forgot this. We have three things. One is called. One more doubt. I'll explain that and explain this. Correct. Yes. Of course. That's why you see every hardware, every microprocessor, internally there will be a unit called increment. Now there were three things other. One is called functionality. I will explain this in the first class. Now I have to explain you now. Performance. And third one is reliability. These three are important for every embedded system. And for you also as a human. For you also, it is very important. Please understand these three very clearly now. Otherwise, both are same. Let me write a program. If both are same, I plus plus, there is no difference between plus plus I and I plus plus. Both are same. Please. Both are different purpose. You cannot use it. You cannot interchange. You cannot interchange. Both are same purpose, but you have to be very careful. One is pre-increment, one is post-increment. Okay. You should be able to have a judgment to find out who said the statement in Google. Google is not the Bible, or Google is not the final word. Somebody could put something on Google. Okay. So please make sure that use your knowledge and find out the statement is correct or wrong. Then you ask me. I'll be able to explain to you that. Both are same. Both are same. If you write X is equal to, I plus plus or plus plus I. Both are same. But If we say x is equal to plus plus I, x is equal to I plus plus, both are different. If you interchange, your program will not work. So please understand. You should be very careful using this increment and post and pre-increment. Now, there's the three things here: functionality, performance, and reliability. The functionality is that very simple. How to use it? When you buy a mobile phone, you will check whether it's having all the functions. You will check all the functions. Oh, does it support the MP3 player? Does it support camera? Does it support everything? But the next important is performance. How good it is doing. When I press the button, does it give immediately, no delay? And third one is reliability. That means that my phone, it works always, never get off. If somebody says that, hey, this phone every 1 hour it will hang, you will never buy it. Now the same thing like you. Oh, Balaji will write a C program, man. He's good. Then, oh, good man. He will cover all the functionalities perfectly. Oh, he writes the program. It's really optimized code. It's really optimized code. Reliability, fantastic. He tests and give you the code. You will never find a fault on Balaji's code. Understand? You will never. He covers all the functionality. The code is optimized for performance, and it is working all the time. Never big a problem. Then they will ready to pay me a salary of 1 lakh. This guy is okay. Balaji is writing a C program okay, but the code is not very well optimized. And somebody have to review his code and do the things. Okay, man. Let him give a salary of 40K. Same way here. Am I right? The phone, the cost. The embedded system, if you have all these things, then the cost depends. That's why, Apple phones are expensive than Android phones. Okay. You should know why Apple could do that. Spend all the time and to make the cost more. Same thing here, your salary. Your salary dependent. You should be confident enough to write a program. You should be confident to optimize the program. Then you should, but without this, should never come here. Without this, never comes here. That's a trick. That's a trick. The mistake what you're doing is, before even you write a program for a given functionality, you try to optimize. Before even doing optimization, you get into the reliability. No, doesn't work. But you always look for shortcut. Your goal is shortcut. You think it's a shortcut, but actually you're going for a long route. Whereas what I say looks to be long route, actually it's a shortcut. Every company you go, every manager asks, they will say that, hey, the only person who success the shortcut is the guy who is good at fundamentals. The fundamentals. Let us do one thing. I'm going to now create a lot of tests. You do take the tests. Never shy of taking tests. I'll give you on the app. Never shy of taking tests. When I give a test, take the test immediately. What I do here is, I will be having a pool of 1,000 questions. From that, I'll take you 10. If you take a test next day, the 10 will be different. If you take a test next day, the 10 will be different. And make sure that continuously on 3 days, you score 10 out of 10. Then you can put pat on you that you are good. Am I right? 3 days. Continuously, you should say that 10 out of 10. Then you tell me I'll go to the next level. These are the ones will improve you. Every day morning you wake up, take the tests. It should take maximum of 10 to 20 minutes. I myself is give you only 20 minutes. I myself will give you 20 minutes. Okay. So understand what I'm trying to say. What I'm trying to say is be perfect on every step. At the same time, too much of time wasting on perfection is waste. Always, if you say that you are slightly getting bored, can talk to me. Come to me. We will discuss. That is what the trick. Now, this we are continuing. Even next week also I have a class. I'll teach you something some more important points what I missed out, like a floating point. I never discussed with you floating point operation at all. What it is, okay? Like what is flops? Okay, certain things which I have not discussed, I'll discuss on next classes. So I'll tell you next week or we have a class. That's an end today at 13 weeks. So please, this 13 weeks is only the start, not end. Don't get confused. This gives you the good idea for you of how to go. But you are all very young. Very young. Take one line and proceed. Don't keep on jumping the line. Let us assume that. Let us assume that you are here. Swim here and come back. So here and come back. If you do like this, you'll be here only. And you take a direction and swim. You will be reaching the very nice goal. So that is sometime what happened on the path, you get bored. Sometime past that's the most difficult. Then you'll be active, then bored. The how deterministic you are to get out of the bored case is become success. Most of the people, the moment they bored, they withdraw to another one. When they get bored, they go to another one. They go to another one like that. That's a mistake they do. Understand that, please? Any other doubts? Any other doubt? So, have a board. Have any board. You can buy any board as you wish. And try it out. For example, here I'll tell you one advantage. Think of a minute. I'll show you the other one. Here, what is advantage? If we go to the WalkMe, I'm not talking about only WalkMe. Any simulator is good. See here. I can work on Arduino, I can share with my code in Raspberry Pi Pico. Then also you see here, there was some more platform. Okay, more options here. See here, ESP32. Okay, you should never able to get this type of options today for you. It was not there in my case. We could not do anything. Today you have all the platform with you. Okay. See, I don't know what stops you from spending on time on this Arduino Nano, a small board. You see here, the small board. You can test it out. So you get so much of expertise in overtime. Okay. I'll help you out all these things. Wherever you get confused, let me know. I can help you out. I'm here to help you that. Okay. Anything else? Any other doubts? Anything? you don't have any doubt, we'll close this class today. We will have it on next Monday. We'll have another session. That day I told you already. This is about floating point operation, which is the one which always people have a doubt about floating points. Once I clear it up, things will be clear. How your computer does, what is fixed point, what is floating point, why floating point, the operations, which is I have never discussed, because generally for the microcontroller operation we don't use it, but when you go for the higher level, we should know that, because in all the controllers today, ARM controller everywhere, we have a floating point controller is there. We should know why they have a separate hardware. Okay then, thanks a lot. If you don't have any doubt, if you have any doubt, you can ask me. I'm available. The best thing is how much you interact with me and how much you are asking me doubts is a trick. The more, see, I'm available. I told you now, if you wanted to, I can explain to you that in and out of even a thing. I'm going to have a session on VLSI also later for our people. Then I'm going to be discussing about PCI Express, USB, all of them. But prepare yourself. Yeah, I'll explain to you that after Monday, after I explain to you a floating point, you will know that how it is. I'll show you the thing. Then you will be able to write the software for 8085 floating point. You write a function. Okay, that's what I'm telling. What I'm trying to say is that the more you interact with me, the more use my knowledge with you. That is very good for you. That's you have a resource available from the industry. Okay, but the thing is that there is no shortcut. You have to go by a right route. But I'm telling you once again, huge potential. I'll I forgot. I'll take about a class on networking or networking controller, not networking. Networking I already taken. My classes are available. I'll talk about networking controllers, about network controllers. In that case, I can request other batch also join. I never discuss about network controllers so far. I'll talk to the people. Okay. Thank you then. We'll meet on Monday evening, same time. Okay. Thank you.